yes, we did start Module 5 last week. Yes, level up. Oh. And we're going to warm up today doing a sprint. Sprints are, as always, are in your fluency book, your Starry Night practice book. Today you can find your sprint on page number 61. Page number 61 in your Starry Night book, and it looks just like this. Looks just like this, and let's double check the directions on that real quick. The directions are to write the unknown number. Pay attention to the equal sign. That sign, that symbol that we say means equal, pay attention to where it is located, and then in turn the other signs as well. So, starting at the top, working your way down, returning to the top, working your way down, doing your best to solve as many problems as you can in the 60 seconds that are allotted. 60 seconds is equal to 1 minute. So I'm going to go ahead and put the time on the clock. While I'm pulling this up, this is you getting ready. If you're not already ready, let's see. Okay, on your mark, get set, go. It came out as a tiny bell this time, but that is the bell. Time is up. I know you did your best. Now let's go ahead and check our work and see how we did. Come on. All right, yes, let's go ahead and check our work. As the directions said, write the unknown number. Pay attention to the equal sign. We're going to go through and check all the answers to our questions. If you get it right, you'll give yourself a check and a little tiny yes. If you get it wrong, mark it wrong, and make sure that that is a problem you know to come back and think about what you did and how you were incorrect in solving that problem. Not that you got it wrong so much as, is it I didn't read the symbols, was it a calculation error, but just give it some thought, and let's go ahead and check our work. All right. Number 1 is 7, 8, 9, 7, 8, 9. 8, 8, 9. 9, 7, 7. 8, 8, 7. The top of column 2, question number 16. 9 is equal to 5 plus 4. 9. 9, 9, 8, 9, 7, 9, 9, 7, 17, 17, 9, 6, 3. All right, count up the total number you got correct. Write that number in the starburst. And then I want you to take a look at, well, actually just looking at all of the problems until we get to down here. So literally 1 through 24. There's a pattern in our answering. There's a pattern in our answering between questions all the way from 1 through 24. What is happening? What pattern do we notice in questions 1 through 24?
Correct. The answer is 7, 8, or 9. 7, 8, or 9 each time. And what about just zooming in right here on 4, 5, and 6? What's happening here? We're going up by 1. As the larger part goes up by 1, the whole goes up by 1. Great work. Now, let's go ahead and continue with our lesson. Come on.
Great job on that sprint. Let's go ahead and move into our application problem, which can be found in your Learn book. Remember, that is the flower beds. Let me see. In Holland. H&A3 on oil on canvas on wood. Was that enough time to get your book down? Okay, so in this book, we're going to be on page number 201. So 201, those are the digits in the number. And we are going to get ready. I'm going to read the problem to you, and the video will prompt you to submit an answer to the problem. So this reads, Anton made a tower 5 cubes high. Ben made a tower 7 cubes high. How much taller is Ben's tower than Anton's? How much taller is Ben's tower than Anton's? Now, before I release you, I have a follow-up question. Are we putting their towers together or comparing their towers? We are comparing their towers. We want to know the difference between the two towers. The difference between them. We are comparing their towers. Good. All right, guys, so let me just read it one more time, and then let the video for you to submit your response. Anton made a tower 5 cubes high. Ben made a tower 7 cubes high. How much taller is Ben's tower than Anton's? All right, great work, great work. Let's compare our results, and this is how I solved the problem. So here we see I have a labeled picture showing Ben's tower of 7 cubes. Then I show Anton's tower of 5 cubes. And then in my picture, I show the difference between the two. Now, I solved this problem as a missing part problem. How else could I have written to solve this problem? And I could do 5 cubes plus some more is equal to 7, which is what I did. Or what other number sentence could we have used to solve this problem? We could take the 7 cubes of Ben's tower, subtract the 5 cubes of Anton's tower, and that would give us the same 2-cube difference. The same 2-cube difference. And the reason we can do that is because these both come from the same number bond. Same number bond. Good. So we can either add with a missing part or we can subtract to find our result, to find our answer. The answer is still that Ben's tower is 2 cubes taller than Anton. So 2 cubes more tall. We don't say more tall. We say taller. But that's what it means. It's more tall. Taller means more tall than Anton's tower. Good job. All right, guys. So we started up with, and we're looking at shapes. Specifically today, we're going to be looking at composite shapes, which is a fancy way of saying putting smaller shapes together to make a bigger shape. So just pictured here, I have 2 squares, and we practice this placed together, and we put 2 squares together, and it's now a rectangle. If I keep putting squares together, I will ultimately make a larger rectangle. We can do the same thing with the hexagon. We're actually going to practice this one a little bit because the hexagon is really fun to make. But yes, so we can actually look inside of shapes and see where smaller shapes are coming together. Look at this large rectangle. You can obviously see the light and the dark squares, but even within that, you can block off a larger square. Yeah, see? It's called composite shapes. So that's putting shapes together to make a bigger shape, or looking at a bigger shape and seeing all the little pieces that were used to make it. So before we do this, let's practice a few of them, okay? So this will be in your Succeed book. But before we do that, let's practice a little bit, okay? I told you the hexagon's a pretty fun one. I hope you have your shape pieces, since we are working on shapes. If you don't have the bag of shapes I gave you, you may have the sheet. I gave you a sheet with the shapes on them too, where you can cut them out. Now would definitely be that time if you have not done so. So if you don't have your shapes handy, or you don't have your paper shapes, go ahead and pause. Go ahead and pause, and then, we'll keep going. All right, so, yeah. All right, so do you have your shapes? Either paper or solid, either or. Do you have your shapes? Okay, good. All right, so tell me, what is this? What is this? That is a marker on the floor. But what is this shape right here? Correct. This is a hexagon. Good. And what is this little friend? Let me see if I can zoom in some. That's a tiny bit. What's this little friend right here? This is a triangle. Excellent. Now, what we're going to do is we're going to use triangles to build a hexagon. Look at my hexagon, okay? I'm going to cover with a triangle. I'm going to match my sides up, and I'm going to keep covering my hexagon with triangles. Go ahead and cover your hexagon with triangles with me. Now, what we want to do is we want to make the sides touch, because when you're building composite shapes, just like in the pictures, these sides are touching, they are connected. So we're just going to keep adding triangles until no more fit on our hexagon. Ooh, look at this. So I'm creating a composite shape. I'm creating a hexagon out of triangles. Now, have I completed my shape yet? Is my hexagon covered? Nope. But if I add just one more triangle, I will have completely covered my hexagon. So that means, this tells me that this number of triangles is required to create one hexagon. How did I do that? I had another hexagon. I think y'all should have two. So let's count. How many triangles did it take to make a hexagon? One. Let me zoom out a little bit. 1, 2, 3, 4, 5, 6. So 6 triangles create one hexagon. Good. Now, the same triangles can be used to make other shapes. So, do you remember what this shape is called? Okay, I heard some of you refer to it as a diamond. What is the math name for this shape? What is this blue shape right here called? Correct. It is a rhombus. It is a rhombus. That blue shape is a rhombus. Now, we're going to do the same thing we did with the hexagon and the triangles. We're going to cover the rhombus in triangles. Was that successful? Was I successfully able to build a rhombus using triangles? Is my rhombus now covered in triangles? This one here. It is. And how many triangles does it take to make a rhombus? 1, 2. So 2 triangles are equivalent to 1 rhombus, correct? These 2 triangles take up the same amount of space as 1 rhombus. So, wait a minute. So if 2 triangles make 1 rhombus and 6 triangles make 1 hexagon, so we have my 6 triangles, right? Let me put them where you can see them. Hold on. I have my 6 triangles, right? And I paired them up. Why did I pair them up? Because we're doing rhombus. So 1 rhombus, 2 rhombus, 3 rhombus. Could I then in turn position my 3 rhombuses? See, look, my 6 triangles are covered with rhombus, correct? With rhombuses. Could I take my rhombuses and make a hexagon? I don't know. Let's check it out. So here's my hexagon, and here are my rhombuses. And we know that 1 rhombus is 2 triangles, because look at it. It's covered. So let's take the rhombus pieces and try to cover our hexagon. Now notice, you can't just put it anyway. You have to put it where it's corner to corner, side to side. So 1 rhombus. Is that a good spot? Can I put it there? I cannot, because we said we want corner to corner, side to side. That could make a cool shape, but it's not what we're looking for right now. All right, so corner to corner, side to side. 1 more rhombus, corner to corner, side to side. Look at that. I just used how many? 1, 2, 3 rhombuses to make 1 hexagon. Let's do a fun one. I want to show you a fun one. So we had those two rhombuses, and I told you this could make a cool shape, but that wouldn't give us what we were looking for. But look what happened if I put those 2 rhombuses and then fill in those spaces with triangles. Did I still make a 6-sided hexagon? I did. That's the whole point of the composite shape. Composite shape is using smaller shapes to build a bigger shape. And this is a great example of how we can combine. We can combine shapes. We can combine different shapes to build our larger shape. All right, so now let's switch off and let's do a couple in our book. Let's do a couple in our book, okay? It's coming. Hold on. All right, so on page 139 in your homework book, and look at this. Look at this. I'm gonna show you something. So if earlier you said no to having your shapes, look what you have here. All the shapes you need. Yes. So if you need to pause so you can cut out your shapes, do so. Don't worry about if you tear the page out, it's fine. Just be careful you don't nick and cut corners off your shapes. But yes, here are all the shapes you need right here to accomplish this goal. All the shapes you need to accomplish this goal are right here. I mean it. I know, right? So what we're going to do is we're going to use 3 triangles to make 1 trapezoid. 3 triangles to make 1 trapezoid. Now, how many sides of your trapezoid? I'm just give you a hint. Trapezoid is the red one. How many sides does a trapezoid have? It has 4 sides. Excellent. A trapezoid has 4 sides, and we said we're going to use 3 triangles to make a trapezoid. So let's look at our 3 triangles. And we have 3 triangles, and we're going to use these to make a trapezoid. Well, that probably means we're going to have to do some things to it. So 1, 2, 3 triangles. How are these 3 triangles going to make this trapezoid? Okay, well, how about this? Let's start by turning the middle triangle upside down. Let's turn the middle triangle upside down. Do you see what I see? Yeah, so yes, now with it turned upside down, because remember, side to side, corner to corner, we can smush them together, and now we have a 1, 2, 3, 4-sided trapezoid. 1, 2, 3, 4. Remember we said even looking at a trapezoid, it looks like a triangle with the tip cut off? Watch, 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 watch. Here, boop, my tip is back. Now I have a larger triangle. Now I just have a larger triangle. So yes, so that is that. So next I'm going to use 3 triangles to make one trapezoid, then add 1 trapezoid to make 1 hexagon. Well, what we're going to do is we're going to take the 3 that we've already established, those 3 that we already established, like, well, I'm not going to do it again. Watch. Let's see if it's going to let me flip over. I hope so. We said, no, you're not going to do it? Fine, I will make you. Okay, so we have this where we just literally went. So now what we're going to do is we're going to attach visually a trapezoid to this existing trapezoid. Now, if we want side to side, corner to corner, and we know that this is our top and this is our bottom, will it go like this? Can it go like this side by side? No. What about this? Is this going to give us me dropping things? I told you I was trying to switch the camera. I'm trying one more time. Okay, 3rd time's the charm. Okay, so this is what we established as correct so far. This is our trapezoid made out of triangles. You know that this is a standard trapezoid, and we know they work because that is exactly the same size and shape. Size and shape, correct? We even said a trapezoid looks like a triangle that had the tip cut off. Now, if we are trying to make a hexagon, which has how many sides? 6. A hexagon has 6 sides. Excellent. If we're trying to make a hexagon with 6 sides, how will I connect this trapezoid to these triangles, which are, also now a trapezoid? How will I connect them? What am I going to do? Okay, so we said that when we're connecting these composite shapes, we want corner to corner and side to side, side to side. Now, based on the attributes of a hexagon, we know it has 6 sides and 6 corners. Well, we've connected our shapes. Let me see if I can get it centered-ish. We've connected our shapes. Yeah, we have, side to side, corner goes count. 1, 2, 3, 4, 5, 6. Is this technically a hexagon? 1, 2, 3, 4, 5, 6. Well, it has 6 sides. Okay, so what do we need to now also check? Does it have 6 corners? Good. 1, 2, 3, 4, 5. It is! This is technically a hexagon. This is a 6-sided shape with 6 corners. This is in fact a hexagon. Does this hexagon look like this hexagon? Do they look the same? Let me see if I can get them in the same frame. That'd be really helpful. You can probably decide what they look like. Does this hexagon look like this hexagon? Do they look the same? No, they do not. Does that make this composite shape, these shapes combined together, any less of a hexagon? Is this still a hexagon if it doesn't look like that? Is this still a hexagon? Yes, because it has 6 sides, 1, 2, 3, 4, 5, 6, and 6 corners, 1, 2, 3, 4, 5, 6. A 6-sided shape and 6 corners is in fact a hexagon, even if it looks more like a plane. Right now it's kind of like a V-shaped plane. Yes, that is still a hexagon. But let's see if we can reposition our composite shape, our combined shape, to make a more official, a more formal hexagon. So instead of connecting it like this, what if I connect it like this? Is this still a hexagon? 1, 2, 3, 4, 5, 6. Yes, this is still a hexagon. Does this hexagon match this hexagon yet? No. Let's try this here. Does this hexagon match? This hexagon does match, and I think that's the shape that you're aspiring to. But all 3 different views created a hexagon because the rules are a hexagon has to have 6 sides and 6 corners. Now, if we're looking to make a perfect hexagon where all the sides and corners are exactly the same, then we're going to want to flip our trapezoid upside down and build our shape like this. See? Flipping it over, still, it looks exactly the same when you rotate it. All right? So yes, now that we've practiced together and you've seen, it's not so much that it has to look exactly like the perfect version, but it does have to follow the rules of the attributes or characteristics. And we discussed that attributes and characteristics means, what does it look like? So for a hexagon, 6 sides, 6 corners. For a square, now squares have to have square corners and all the same size. So only one right way to make a square, okay? So yes, you're going to be completing your problem set, and I did say completing your problem set. That is in your blue trim learn book, found on page 203. That is the front, and then there's also the back. So front and back. For your problem set, leave your Nearpod. Like, you know, after the video, there's a slide that shows you a picture and repeats to you the page number and everything. Leave it there. Do your problem set. Come back. Complete your exit ticket. You can use 3 rhombuses to make a hexagon, and then you're going to use 1 hexagon and 3 triangles to make a large triangle. Yes, I want you to draw this. Does it need to be perfect? No. Could it be a good idea to, well, I don't know how you trace it on your device, but no, yeah, just do your best. Do your best. Do your best to draw to make the shapes that you're being asked to make. I will split it between 2 draw slides just to give you a little bit more room to work. But guys, that's all I have for you today. I can't wait to see you a little bit later. And I'm really excited to see the composite shapes you come up with. But until later.